Hi, good morning, and thank you for joining me in my shop. Today is June 5th. It's a gray, rainy day outside, so I'm happy to be in here. You can see all the capacitors that I've removed from this radio. That's quite a few. It's a big radio. Got a lot of stuff going on. There's still a few of these left in there. One in particular is in the motor circuit. Don't worry about that when I get around to dealing with the motor. Today, what I'd like to do is use the information in the service manual to check voltages throughout the radio. It's a good idea. It could lead to more trouble being found in the radio. I could find a voltage that's gone low, and maybe that would track to a resistor that's gone high, or something like that could happen. So with the information available, it makes sense to go through the radio and do that. It's a bit of a tedious operation, so I'll just probably show a little bit of it on camera so you have an idea of what I'm doing, and then I'll just continue on and do it. Let's see, I don't know. I think I'm going to stop now though. I'm going to start drinking coffee right away. Yeah. Okay, so I have the diagram here. It's laid out the same way as the radio. So for instance, there's the volume and tone, and there's the volume and the tone. So I can use this diagram to fairly quickly go through and contact the proper locations in the radio to get the voltage that they have written down here. Then I'll just mark this off as I go, and if I find something that's dramatically out, I'll make note of it, and then we can hunt for why it would be out. Typically with a radio working this well, nothing is going to be way out, but you really don't know until you check. So that's what I'm going to do. It's tedious work, so I'm not going to do it on video. Do it myself. Okay, maybe I'll let you watch me do the first one. You get a better idea of what I'm up to. So, radio's operating quite nicely too. So we're going to start with this tube down here, and it shows 190 volts on this pin, and that's the only voltage it's showing here. And I can see 190 on that pin. So that pin would be this one here. So 500 volt scale. That was the 150 volt scale before. And so I'm reading 180 volts. And we're supplying the radio with 114 volts. So that would check out as okay. Why don't I just keep going here, because everything's going great. Let's just keep going. I have another 190 volt over here on the next tube over. Should be right here. Oh, that one's a little low. That one's showing up at 140 volts as opposed to 190. So that might suggest this, whoops, right over here, this resistor here maybe. You know, you really have to stop and think about. Okay, I stopped and thought about it. I was going to say, is it really enough to worry about? $140. Well, I'm going to write it down there. Okay, now you got the idea. I'll carry on my own now, and I'll show you the results. Okay, that didn't take very long actually. Much quicker than I thought. Might be hard for you to see the green dots I have here and there. Every voltage on here I measured, and they're all very, very close, except the one you saw me do right at the start. This is the only one that's off. 190 is what it should be, 140 is what I'm measuring. Let me repeat this measurement, and then we'll investigate why this voltage might be off. So it's the plate of this tube. Okay, so it's right here. So I'm reading 140 on the meter there, and it's supposed to be 190. So that's a, you know, maybe having no bearing on the operation of the radio at all. But why don't we look into this? I bet you it's this R12 right here. I don't know, I'm just guessing. Okay, we need to take a look at the schematic.
many of those worst roads are here in Toronto. 3 of the top 10. Eglinton Avenue West, number 6. Gardner Expressway was number 9.
Once a year, the province makes a list of...
10. The list pretty arbitrary. There's nothing to compel the municipality to actually fix those bad roads.
It's just something that's done for fun. We make a list of the 10 worst roads in Ontario. So somebody does this, a radio station or somebody. And yeah, and one of the worst roads in Ontario is not far from my house. It's just a block away, which they're working on right now. Okay. I don't, everybody's got roads. Everybody's got roads that need work. Nothing unusual about that. So, right. Coffee break time. That sounds like a good idea. Okay, let's take a look at the schematic here. The 190 actually measuring 140 is right here. You know what? It could be. No, it's number 7. Right. So it's right here. So how does this plate get its voltage? It gets its voltage through this resistor, and then it's down here to the power supply right here. So it's wired right from here. Other elements in the radio are getting the correct voltage, so there's no problem in the power supply, because this power is sent off in different directions here. One direction's up here. Here it splits, goes through a 220K resistor to the plate, and same thing down here. These two circuits are basically identical. Same tube, also 6F5. This one does have 190 on the plate. This one doesn't. The only difference is this resistor. This resistor must be the problem. R15. So should be easy to find, but let's look on the diagram here. R15. Oops. Okay, R15 is going to be right here. So 190. Where's R15? So maybe they haven't shown it. There's no, yeah. No, there's no resistor connected to this plate. What's going on here? So they're not showing how the supply is coming in. They're not showing R10 on this diagram. I think that's what it amounts to. R12, R15, and no R10. They're just not going to show it here. Okay, looking again at what it is. R10. On the, over here. Down here. Here we are. Ooh, it's not R10. How did I get R10 out of this? It's R15. How did I get R10? I don't know how I did that. R15. So let's look for R15. Still not showing up. Oh, there it is, R15. So somehow R15 is affecting the voltage down here. The idea is the voltage gets, I got the schematic again. Can you flip it? Yeah. So if we're looking here, oh no, we want the schematic. Sorry about this. I'll turn around. Again, plate through R15, and then nothing else, all the way back to the power supply, all the way back to this resistor on the side of the radio. So it's just it just goes through R15 from the plate. The plate is pin number they don't give you. But they showed over here though. So R15 is shown on this tube. While I'm measuring the problem here. I got around in a circle. So they're just not showing wires, I guess. And maybe what it is this is an unused pin. Notice they didn't label it here. This is an unused pin, so they've made a connection to it. Same thing's going on down here with these two pins. So probably the primary comes up here. Probably R12 is the same as R15. This is probably the other 220. So that's the one I'm after. Right there. Okay, let's look in the radio. Look in the radio. Now, turn this way. R15 is coming up like this from down here. Well, somewhere in there is a R15. Look, we need to take a close look in there. I'm going to shut off the radio before I do that. I think it's coffee break time here. Okay, you can see I have a camera sitting right here. We're going to look through the camera, and here's what we see. So, let me point at some things. I'm just trying to verify myself to make sure I have this right. Now, first of all, where's the pin that had 140 volts on it? It's this one up here. You can see my little stick touching it. Has this capacitor hooked up to it here that I put in. We follow this down. It's kind of obvious. It's got to be this resistor. This is then going over. There's a similar resistor going to the plate of the next tube. And this red wire you can see here is carrying the B+. That's what's not on the schematic. So pretty ugly to look at. Now, should I bother trying to read that resistor? Why not? We'll take a shot at it and see what value I get. It's in a circuit. It's in a bit of a complicated circuit, so this may not be any kind of valid reading here. What was it supposed to be? What was it? 220,000 ohms. 220. Okay. 220, eh? Well, I have another one right beside it I can test too, which should show 220. So this first one is the questionable one. My expectation is it will read like 300. Okay, we see that 285. Okay, now here's the other one going to the other tube. 240. Well, they're both high. They're both high. Supposed to be 220. And then let's go back to the first one again. I can get there. Here. 285, and this one is 240. Meow. Meow. I'm speaking cat, in case you're wondering what language that was. What is it? What's the situation? I think he's just bored. He wants to play around. Okay, I think we might as well just change both those. Why not? I will get down to that in a moment. So what I'm doing here is I'm trying to put the two resistors kind of together in a shape that will kind of pop into the radio. So I'm just soldering the two of them together here, and then get rid of part of that cutter space. What'd you do with them? Is this is going to sit in like that, except this has to bend over like that. This would fit in. Need to put a shrink sleeve on there. Okay. Now I need my better cutters. Here they are. Right here. Okay, out with the old. Yes, I'm on my knees here doing this. We'll leave a little bit of wire here. you do this work long enough, you'll eventually learn the lesson about cutting the wrong thing. When the cutters come out, you get very careful. You cut the wrong thing, or when you're cutting one wire you don't see, you're actually cutting two. You can't see the second one, it's hidden from view. And those things, those kinds of mistakes, they are hard to find. There we go. Okay, two bad guys out. Two new guys going in. Let me just size it here. Yeah. Okay. Very tight in there. Okay. I'm going to put those in and solder them up. We'll try the radio. Okay, let's take a look at how I did there. There's the two resistors. Grab one. Oh, funny. It sounds like a cat when you squeeze it. They're good. Okay, and this one goes up to a terminal up here. No shorts. We're good. Good. Very good, because this is the challenge I have while I'm trying to shoot these videos. This is what's going on all the time in the background. Okay, tall stander. I think it's time to run the radio again and make sure that it's still operating. So good. Okay, let's. Oh, he's gone. Let's do it. Quick, while he's gone. So I have to do a little cleanup here, which I mentioned this morning. I try to police myself to clean my bench a little bit just before I turn something on, which is a good idea. Oh, he's back. I thought you were leaving. You're not leaving. The reason for having a clear bench is if something starts happening, then something unexpected starts happening, there's a degree of panic that will start rising in you, of course. And with the panic happening and stuff all over your bench, chances are your brain will just go and you won't be able to act appropriately quickly. Not that I'm expecting it, but see, that's when it happens, right? When you don't expect it. It's just going back and forth, trying to keep up with me. Okay. Put this over here. Go up in the world. Okay, you work on the lighting. There's two more soldiers out. That's it. Take up your position on the keyboard here. Okay. Now we're going to plug it in. Antenna connected, speaker connected, everything ready to go. There we are. Any smoke come out of there? Nope. No, there won't be. According to the schematic, those resistors were 1/10 watt. I didn't know there were. So I thought 1/4 watt was the smallest size. So. Just, what are you chewing? No, don't chew on those things. Okay, Kat, should we turn up the volume and see what's happened here? Oh my! Whoa, 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 whoa! What has happened? Uh-oh. Uh-oh. Uh-oh, something not right. What is it? Okay, without panicking. 73 volts on the radio. That's probably what it is. Without panicking. No panic. Why is it pulling it down so much there? How many watts? Take a look at the watts here. 94. It's going to settle around 90 watts maybe. I think that's normal. 114 volts. Oh my gosh. So this kind of thing happens to me all the time where I go to make a change in the radio to normalize it, and its performance goes down.
You'll be there for me. Tell your MPP that recovery is possible. Visit one step forward.
How can that be?
From the backyard Tompion, all the machine shop, Metal Supermarket has what you want.
That's just paralyzing. That is just paralyzing. Let's check the voltage on those. Check the voltage on those, Jim. Or is it just tuning? No. No, there's no way I was trying to.
Get the job done.
That's full.
Call us.
Before, no, look at. Okay. Second voltage. What are you doing? No, you don't want to play with that. Okay. Oh, my poor cat here just did something. Here, what about this little chunk of? Hey, look at this. This is. Oh, that'll keep him preoccupied for a bit. Okay. We're supposed to find 990 volts here. I'm on the 500 scale. 190 is right about here on the scale. What do you got? So 150, that's slightly higher than it was, and the other one well, that's all bad. That was very bad. That last little thing there was really bad. Yeah, so, okay, I'm going to stop for a little bit because obviously I made a mistake and I think something just suffered because of it. Oh, no, don't say that. I'm going to go hide away for a little bit. Come on, Bert, let's go play somewhere else for a little bit. The fun is drained out here briefly. Well, you know, I'd be kidding if I said this wasn't upsetting. This is very upsetting. Does that make sense, what I just said? I don't even make sense anymore. Well, let's take a close look and see if I did something dumb here. That's the first thing. And no, I didn't invite you, Bert, to come and see the dumb thing I did. But just come anyway, because he'd like to see it too. Would you? You want to see the dumb thing? Well, you're going to have to look at another screen. What is the dumb thing he did? Okay, I need a stick. Okay, looking very closely. 2 resistors soldered to the terminal that the red wire comes to. Did it short into this wire here? Sure doesn't look like it. No, so the stick I'm using now, I'm controlling one end and the cat is controlling the other end, which is, you really do make this tricky. Now, yeah, this is what's going on here as I poke around. They love the stick. Did I solder it to the wrong thing? I don't think so. There isn't too many options here. So come on. So there's 2 pins here that are soldered together, and then there's a small capacitor coming to it. And really, I don't even have to do that. I have a diagram, for crying out loud. For crying out loud. You can tell I'm getting upset, eh? Not good to do this work once you get upset. You get frustrated, all that kind of stuff. You can't think straight. You might think you're thinking straight, and that's why you're not, actually. But I think I'm still thinking straight. Well, I'm thinking as straight as I ever think. Okay, so quite clearly, these things are... Deep breath. Calm, cool, relaxed. Okay, I'm ready to go again. So if these things are connected correctly, what happened? What could have happened? I didn't do anything else. I did not do anything else. I dropped a tidbit of wire into the radio. Did I do that? Maybe I did that. I don't think so. I did drop a tidbit, but it just fell onto the apron here, and I know where it is. It's just right here. It's right here. Did I drop another tidbit in there? Maybe I left a, sometimes I don't trim the wire off, you know, after you make the connection, you have some excess wire sticking out. Sometimes I don't trim it away. I forget to do that. Did I make a cold solder joint? Oh, wait a minute, what's that? No, that's a lead from the capacitor there. Did something come undone while I was doing this? That happens too. I don't say anything, but I just hear. Oh, okay, what are you listening to? Yeah. That must be pretty interesting on the video. Okay, come on. I'm going to turn this one off. Oh, it is off. Oh, I didn't know that was off. Turn it off because. What is going on here? Here, I'll give you a chance. There you go. Okay, you can't be playing with my microphone like this. Why is it so? What is with you? What is with you? Come down. Come down. Come down from here. Last grab attempt. Okay, talk to all the nice people here. Tell them how much fun you're having. How much fun are you having? Tell them what's wrong with this radio. Yeah, that one. That radio. What can you do about it? Ooh, he wants to fight. Do you? You want to fight? Okay, I'm putting you down. Okay, that's keeping me very good. Good cat. Just crashed everything here. I gotta stop for just a minute and get my act back together here. I had to close my shop door and keep the cat out of here for now. I cannot find anything at all that is in any way out of sorts here. The problem is I had the radio operating for what, about a minute and a half, two minutes, and right at the end of it, when I turned it off immediately, something happened. What happened? I got no idea. Did the radio suddenly start working and it just freaked me out? I turned it off? I don't know. The problem is turning it back on will conceivably put it right back into that state, whatever that state was. The concern here always is burning out a coil. I am fooling around with the plate connections, but I don't believe there's any coils involved. I think I'm probably full of crap when I say that, because the plate usually runs through a primary somewhere. Maybe not with these tubes. So I'm really stuck here. I'm scared to turn it back on. They did make a measurement and found the voltages to be different. Yet these two tubes, as far as I know, are operating essentially the same, with the same everything, and so they should be the same everything, but they aren't. Now each tube could be a little different. One could be a little worn out, maybe, and so it's not drawing as much current, making different voltage drops, so I get different readings. But I can't. I'm scared to even just turn it on and just make the voltage measurement again. And what's that going to show me that I didn't already see? Anyway, I can find nothing wrong anywhere. Yet something is wrong. What do you do in a situation like this? First, I should cut the power to the thing here. Run the radio on low voltage and see what happens. And what am I going to see that's going to happen? I'm going to repeat the same thing again. It's going to operate for a while, then click to this hum thing, or it's going to come on and hum right away, or was that just all nonsense anyway because I turned the radio off so quick? Whatever happened had happened already, so it was kind of turning it off too late. in the game. Never saw any smoke. Didn't smell anything at any point. Any dramatic current variation would be because of a problem with these resistors I put in, but there's nothing going on there. They themselves didn't smoke. I get nervous. I start doing the finger thing. And so this is actually the worst case for someone like me fixing somebody else's radio, where it's working great. I do something, and now it's shot. Turn the volume up a long way so you can hear the signal. These are the front end. No, these aren't. This is these are the inverter tubes. What am I thinking of? I'm thinking I'm working up in the front end here, but I'm actually way in the audio. Oh, okay, that's actually good news to me. That's some good news to me. Okay. Yeah. There's the good news. The good news is there aren't coils up involved in this. That's the good news. If you're in the radio part, you have all these coils that are at risk. Should you do something dumb? Generally speaking, misconnecting a capacitor, nothing untoward is going to happen, although the radio may behave really weird. Misconnecting a resistor may allow current to flow in places it's not supposed to flow, and you get a result that, not a happy day result. Cold solder joint. I can't see it. I can't see it here. The radio's off, but let's just. I'm trying to rip the connections off the terminal. If they're cold, you can tell if the connection is cold. Cold solder joint. Let's watch me try this out. I'm looking down here, and now up here. They're solid as can be. Short, I can't see. The thing is, the radio did not work right off the bat. Right off the bat, it didn't work right. So that means something was wrong right after I changed these two resistors. What is it that's wrong? What has gone wrong in here? Oh my gosh. I'm really paralyzed now. I'm scared to turn it back on. It's in the audio circuits. Not so much at risk. Now I'm tapping my foot. I don't know. Where are we on the clock here? It's 11 o'clock in the morning. Got rainy day. I got time. Well, maybe I'm going to give this a few minutes to boil in my brain, and maybe something will come up here. Oh, I think Bert has gone for a nap, so good thing. So I have a theory here. It's really lousy, but here it is. Okay, see that black capacitor there? Could that have shorted out? Probably not. But I was applying heat to the terminal it's soldered to, or did I? Did I? Let me look at it here. I did apply heat to the terminal that capacitor is attached to. So did I pooch this capacitor? I'm just looking up here too. Didn't do anything up here. See, this terminal, tube terminal, and this one are tied together with a wire. And and that, I believe, is going off to another. What is that? That is another capacitor lead. heading off this thing here. So, okay, did this short? That's an easy thing to figure out. Let's find out. I would really be surprised if this turns out to be the problem. The difference in voltage between the two similar tube plates there has kind of got me wondering. I'm wondering about everything. And so we'll just put this on the lowest resistance here to start anyway. Okay, across that capacitor. First checking the meter. Yeah, and now the capacitor. Yeah, no, not shorted. We go way up here, 6 megohms now. Okay, that theory went down the drain pretty quick, but it was a bad theory. Oh my gosh, I just have no idea what could have happened here. Well, there's some kind of debris down there. What's that? Can't quite see it in this view, but if I can look at this one, yeah, there's some. That looks like a. I don't know what that is. Let me poke it out of there. I think that might be debris from the capacitor. What is it? I don't think it's doing anything anyway. It's just some junk here. Yeah, I think this is some of the debris that came from the capacitors. So I don't think that would be any. Well, sooner or later I have to turn this thing back on and find out. Like maybe some solder dripped down somewhere. Huh. Somebody came loose. Loose here, I haven't noticed. No, those resistors are solid. They did a good job. Now there is a tidbit thing happening down in here. Or not a tidbit, but like a white, this thing right here. So that's not touching anything. Did the red wire come off? I can't, because when they do these in the factory, you know, they wrap a wire around the terminal. There's no way it would just come off from soldering it. I'm left with only one option. That's to turn the radio back on and see what happens. I don't like the option. Okay. Once again, the good thing is the trouble seems to be in the audio circuits where there's much less risk. Why do I think it's in the? Only reason I think it's in the audio circuits is because I work down here and I'm totally involved down here now. It could be anything happen somewhere else in this radio, just a total coincidence. A total coincidence. The radio is still working, just the volume dropped way off. Wow, that really points to the situation down here. You know what I could do? Maybe I'm just going to resolder these connections. Just heat them up, and then we'll check it. So So what would happen, like there's two tubes here, one is just an amplifier and the other is an amplifier inverter. What if one of them wasn't operating? You would still hear the signal. You would still hear the signal. But I think it would be distorted myself. I think it would be terribly distorted and the volume would be way off. Is that what we were hearing? One of these tubes shut down? How could it shut down? I looked, there was plate voltage on both of them. How could they shut down? I checked the resistors. They're brand new. I checked them. They were very close to the 220K. It is 220K. It is 220K, isn't it? Is it? Is that what I did? Could be. Let's look again. Okay, so we're looking for, you know, I did it. Yeah, I came down here and I saw them. 12 and 15, 1/10 watt, 220K. 12 and 15. Oh, it's way up here. Wait, I can go over here. 12 and 15, and we see 12 and 15. I got the right size in there. This is the one that I thought might be shorted, but no. So this is the cathode circuit here. It's grounded. This capacitor, the one I just checked, is tied to ground from the plate. When I did the resistance reading, it showed a tiny amount of resistance. Which I thought, well, what does that matter? Maybe it does matter. I should change this one. C23. Because why not? C23 is to the parts list. And C23, look how they've done here. I gotta go down here and find it. C20. Looks like 32 twice. Where's 23? Let's zoom in on this. Oh, that's not gonna help. C23. Oh, these are really difficult to read. That looks like 28, 29. That looks like 24. 23. Somebody show me 23. 22, 32, 31. Oh, come on. You're not going to show me 23. Uh-oh. Here come the cats. The action is starting. Let's look again. This is the entire list. Are the capacitors anywhere else in this list? I don't think so, no. All here. Right from here. The rough size of the capacitor I don't know the rough size. I know the exact size. I know the exact size because it's over here. The exact size. No, I don't. I just know the number. I don't know the exact size. 23. It's on the schematic. It'll be on the schematic, Jim. 23. 23. 23. It's in the audio area. 28, 25, 24, 23. There he is. Right there. 23. 100 picofarads. Okay, now we go back to the parts list. We look for 100 picofarads. This is 23 right here. 100 picofarads. Okay, I'm gonna change it out. Just on a whim. Okay, capacitors out here. These are generally, well, these black ones may not be the most reliable, but this type of capacitor is usually quite reliable. Let's find out. I'm bound to put a new one in now anyway, but let's just see what this guy says. This amazing little tester here. There we are. 126 picofarads, no loss. It's supposed to be 100, and it's reading 126. Sounds perfectly fine to me. Well, I'm sure I'm barking down the wrong tree. I'm barking down. I'm not even barking up. I'm barking down here. Okay, so I'm gonna put this guy in, and we're gonna gamble and turn on the radio again. You know, the more I think about what has happened here, the less sense I can make of it. Which means, you know, in that case, something has happened that I can't imagine. Something totally unrelated to what I was doing took place in the radio. I don't know. But okay, I did say I'm going to try starting it up. Well, start it up with the dim bulbs, of course. Well, that only allowed the radio to come up to 73 volts last time. That's really kind of low for it to expect it to operate. Around 100 volts, 90 or 100 volts, it should start operating. So maybe we'll kind of turn it on and crank it up to that level right away and see and watch what happens. I don't know what's going to happen. It's really quite. Think about this. The last thing that happened was it began to hum. So what if I turn it on? The first thing that happens is it's humming like that. What am I going to do? Well, one option is turn it right off again, but that's not getting me anywhere. I don't know what to do. Did the antenna fall off? That's that simple? No, the antenna's still there. Okay, here we go. Dim bulbs, and I'm going to flip it on here. So I'm moving the camera so it doesn't block my way when I run for it out the door. That's not true. I'm letting you see the dim bulbs. Excitement here of it all. I really am nervous about this. Here we go. Make sure the volume's up about halfway. Anything funny happening? No funny. 88, 89, but it'll start going down. Now it's going down now. 79. Nobody's going to be home. It takes a long time for tubes to heat up when you run it with this low voltage, like a long time, like 2 minutes. But it probably won't. So we're going to crank it up a bit here. Now I put the camera. I have to move the camera. So the dim bulbs are going to stay in the circuit. And I'm going to crank up the source voltage, and the result will be the voltage will go up here. Okay, cranking up the source voltage. Didn't go up much. 77 volts. It's just not enough. So that's all I got there. 78. Ooh. Okay. Everybody hold the fort. Could it be what I did was I ran it on the dim bulbs? Where'd the hum go? Where'd the hum come from? There's no hum. There's nothing going on. Radio's working. I think maybe I did it on the dim bulbs and forgot. Okay, going down. You got to back this down. Back into the normal range. Okay, now we're going to go on straight on. Whoops. Straight on. Okay, we're running with 88 volts. Okay, we're going to run this up now to the proper voltage, 110 or so. Find out how stupid I am here. Okay, watching this guy. $113. Ooh, got there quick. I can hear the glass creaking in the tubes. It's freaking me out.
Operating.
I think we lost a lot of volume there.
Footage showing a human to get
It's working anyway. And what about that crazy hum thing?
We'll look into that. We'll also look into what the UK is doing and Canada is not. What is that? You want to know? We'll tell you. There's a 640 Toronto for the iHeartRadio app.
640. Strong station.
Those tariffs will have zero impact on the prices it spends.
Zero?
We pay Canadian workers to manufacture all our engagement rings right here in Canada. Always have, always will. Our state-of-the-art manufacturing facilities are superior.
I'm just waiting now for something to happen.
Other countries.
Hell yeah.
Specs will not be raising its prices.
Let's check the voltages down here.
Across from Scarborough Town Center, near Square One in Mississauga, and next to Colossus Theater in Vaughan. It's Ron at MotherMortgage.ca. If you're buying a home and you need a mortgage, please do
Okay, so we're supposed to get 190 volts right up around here. Here, 150. And the other tube, 250. What is wrong here? They're supposed to... Ooh, what was that? Am I doing this? Maybe I should switch those tubes and repeat this test. Getting a low voltage here and a high voltage there. The two tubes are the same tubes. Right. I'm dumb enough. I need to be absolutely sure of that. So let me just take a peek. And yes, they are both the same tube, 6F5. We'll swap them around, turn the radio back on, and find out if the tubes are. You know what? I can't do it right now. They're hot. I gotta let them cool off. Okay, I gotta cool off too. Everybody, cool off. Well, I was just getting ready to pull those tubes out, and I saw something I saw before that I didn't really think much of, but maybe it's a little more to it. In the documentation for this radio, they talk about using metal tubes. So you can see like a metal tube here is a little bit unusual. But these other metal tubes, like this one, these are common tubes. If we look at the 6F5s, if I can get my... Yeah, let's pull this out here. Have a look at the two 6F5s in this radio. It's this one and this one. Well, wait a minute, this is a glass tube. This is a metal tube. What's going on there? So I'm looking at the cap connection and trying to understand if it's pulled tight, because this is a tall tube and you'd think the wire here wouldn't reach it in the first place. But they're different. I mean, they're both 6F5s. One is metal, one is not, and maybe that's where the difference is coming from. So I need to find another... I'm going to pull these out. We're going to reverse them as I planned, make the test, see if the voltages have transferred. Then we'll try to test both these tubes, see what's going on, and then perhaps replace this one with a metal tube. The thing about a metal tube is it has a shield. The metal is a shield. This tube has no shield on it. It's probably quite inappropriate to have this tube here, despite the fact the radio was working really well. Let's get this guy off here. You see, there isn't really any slack in this wire, but there's a fair bit of slack in this one. So I think that's probably what's happened, is somebody's replaced the original metal 6F5 with an older glass 6F5. That would be my guess. Don't break the strings, that's all I would need to do. Okay, so this tube comes out. I wonder if I should test them right now. No. Stay with what you're doing. I don't like pulling on the glass bulb. I don't remember pulling this tube out, actually. 6F5. 6F5, definitely. Westinghouse Radiotron. And this guy here, hard to get a grip on it. It's out. 6F5. General Electric, made in Canada. Radiotron. Okay, so we Now I'm going to try to put the glass one in. You know what? It won't fit because this is too short. It's a shielded wire too, but it's longer. It's longer. They wouldn't possibly. Oh, I'm sorry about that. That's my cat snuck in here. Is chomping on the microphone again. Oh my God! I'm telling you, I can't keep ahead of this guy. I thought he went to sleep. Didn't you go to sleep? I thought like you disappeared. Your brother was around. Yeah, my other microphone. What is with you? No. Okay, clearly I've got to stop at this point, or this cat's going to end up part of the radio down below him here. Look, you're knocking stuff over. Oh, I can't get him from up there. I'm in trouble. The disaster is happening here. No, don't lick the microphones. Go over here. I'm going to try to get you. Oh, yeah, now he's gone behind. You're really causing trouble here, cat. Come over here. Over here. Over this way. Come over here. Keep coming. Don't stop. Keep coming. Right there. Good. Now I got you. I got you here. Oh my gosh. Oh, such a troublemaker. Just anything at all to play with. I need something. Get me down from here, he's saying. Holy smokes. I hope you're enjoying my cats. Go out the door. That's a good cat. Good. He's out. Door's closed. Right. So swapping these tubes and this wire maybe pulled it up from under. There's just no slack underneath. I don't know, man. I'm getting a lot of mixed messages here. Why would they do a glass one and a metal one? They wouldn't. So I'm not gonna be able to I'm not gonna be able to do the swap thing. So what we'll do is, oh my gosh, what have you been looking at? Okay, I lost control of the camera. So let's test these two tubes because that's really all I can do. I cannot swap them and sort of test out the situation that way. Okay. I gotta set a few things up here. Okay, I think we're set. This is the Magic Eye tube, which I just left over here to keep it safe. And we'll do the glass one first. I should double check my settings. 6.3. So dark here, I have to do this. So signal 1, 20L 27030. 27030 0610 0610 37 F. Okay, everything's set, and the pass is basically 1,000. And you have to apply the grid cap. This is the grid cap. Okay, we'll plug this guy in. Where are all the pins missing? They're not missing. They're not required. Okay, and we'll put on the cap. You know, I don't remember. I never realized or took into account that these two tubes were of a different sort. Now, supposedly they'll work the same, but I'm not sure. They may test the same, but they may work a little differently in the radio because there's no shields on this one. I don't know. Okay, ready to check for shorts, so we're watching the meter here. No shorts coming up. Okay, the test result should be above 1,000, above here. Oh my, that's quite low. That is quite low, because this 1,000 is the reject point. This means throw the tube away at this point, and it's way down here. So yeah. Oh, I think the cap just came off. Yeah, the grid cap is loose on this tube. I think this guy's not long for this world. He's going over here. And I'll get the other 6F5. There it is. Also, pins missing. Don't want to put pins in that aren't needed. Cost money. Okay. Here we go. A minute or two. Well, 30 seconds anyway. Okay, yeah, I do think I remember now testing one of these tubes and finding it low and kind of thinking I'll have to deal with that later. Okay, here we go. 1,000 again, right up here. Oh, it's also way down there. Hey, that's not good. That suggests the tube test is wrong. The two tubes testing both low? Wait a minute. Wait a minute here. We're going to jump to conclusions. 6F5, signal level 1, 20L, 37. Yeah, 37. F. Two bad tubes. Really? Well, you know, it would explain low output, low audio output. But it wasn't low before. But, you know, is it possible you can operate the tubes in a less than ideal circumstance from the tube's point of view, but get better output from it? Maybe. Well, you know what? All I can do is find two 6F5 tubes to replace these two, and see if that doesn't boost everything up again. Very odd. Yeah. And that's it. That's going to be it for today. I have to spend time hunting the tubes down and all that kind of stuff. So that'll be for tomorrow. And so thanks a lot for watching. It's a little bit of an up and down ride here. I really didn't get done what I wanted to get done today, which was to get through the IF alignment. But I got derailed. Thanks a lot for watching. See you on the next video.